Welcome to the eighth live session of Principles of Industrial Engineering. So today we will be discussing on network-based approaches such as critical path method and project evaluation review technique. So these approaches are used to assist planning, scheduling, and control of the project. So we will discuss some theoretical and basically some crashing and network related questions and further solve the questions. So purpose of the dummy activities in a network is which of the following? So first we will discuss like what is a dummy activity. Dummy activity does not consume any time and resource. Dummy activity does not consume any time and resource. They are used just to preserve any logic or precedence relationship. So the correct option is option B, to satisfy precedence, and this is shown by dotted lines in the project network, and this should be used only when it is very necessary although there is no restriction on the number of dummy activity that can be used in a project network. So this is about dummy activity, and we will also see a short example where you will like suppose this is a network followed by now this is another activity. Okay, so these are the events, head event, these are the events, and these are the activities. A, B, C, D are the activities. Now we will connect these events through a dummy activity. We can connect it like this and we'll term it as dummy activity. So in such cases we can use a dummy activity. Okay, So moving on to the next question. CPM and PERT are associated with which of the following? Human resource techniques, assignment techniques, project evaluation techniques, or none of the above? Well, the correct option is project evaluation techniques. Well, these are CPM and PERT are CPM is critical path method. PERT is project evaluation and review technique. Now these are network. So these both are network based approach which is used to assist planning, scheduling and control of the project. Now we will briefly little bit go about discuss little bit about what is CPM and what is PERT. So CPM is the critical path computation method and PERT is the project evaluation and review technique. Now PERT is based on three time estimates to complete an activity. This is used for certain projects. These three time estimates are T0, TM and TP. Now, what is T0, TP and TM? Again, this is T0 is the optimistic time, TP is the pessimistic time, TM is the most likely time. Now, PERT is used for certain projects and it is based on, it is not used for, like PERT is used mostly for uncertain projects. Uncertain projects, and it is based on three time estimates to complete an activity. Now, P0 is the minimum time required to complete an activity when everything goes according to the plan. TP, pessimistic time, it is the maximum time required to complete an activity when everything goes against the plan. This everything goes according to the plan. Now TM, it is the time required to complete an activity under normal conditions. If we draw the graph, this is the probability, y-axis, x-axis, this is the TM, this is the TP, This is the T naught. Now TE, this is the expected time, is equal to T naught plus 4 into Tm plus Tp by 6. TE, expected time, also this variance, if we can find out, it is Tp minus T naught by 6 whole square, variance of an activity. I'll write briefly about optimistic time, most likely time, and pessimistic time. Minimum time required to complete an activity when everything goes according to the plan. Time required to complete an activity under normal conditions. Maximum time required to complete an activity when everything goes against the plan. T naught, Tm and Tp. Now we will discuss briefly little bit about the CPM method, critical path computation method. Critical path computation. Here we find out total duration needed to complete the project. Also we can know classification of activities of project as critical and non-critical activities. Now, how to solve? We will go and see in the further questions by solving a numerical. So, major things which we need to realize in this, that here we draw a network diagram where we calculate the forward pass computation, backward pass computation, slack time, activity duration, and finally the critical path also. Okay. Moving to the next question. The particular task to be performed for progressive project in CPM is known as which of the following? Okay, the correct option is C, activity. Now I'll briefly explain what is a project. Project, this constitutes of activity. Now this is interdependent. That means something which consumes resource and time. Now, what is a project? Group of interrelated activities that are to be performed in a proper sequence. Activity is part of project that consumes resource and time. Now, next is events. Events are used to show starting and finish of an activity. Like, this is an activity, this is a head event, this is a tail event. Tail event. So the particular that so for to perform a particular task, we need to identify or carry out the activity. The next question. Total time duration is estimated in PERT by, I just discussed this. How do we calculate? PERT is T naught optimistic time, Tm most likely time, Tp pessimistic time. Now this is the correct Te is the expected time. The correct option is T naught plus 4 Tm plus Tp by 6. Option B. This is the graph, and our projects normally follow Tm, Tp, T naught. This is probability. We all are familiar with this graphs, and it is the moving average method where the maximum weightage is given to moving average method, where maximum weightage is given to Tm. Okay. And we know what is PERT. PERT is project evaluation and review technique, or program evaluation and review technique, and it is used for uh, based on three uncertain projects, and it is based on 3 time estimates to complete an activity. Mostly R&D projects where we cannot say when project will end, these follow PERT technique. Okay, so the next question, activities A, B and C are the immediate predecessors for D activity. If the earliest finish times for the 3 activities are 10, 12, 5, then the earliest start time for D will be. Now we'll understand. If this is an activity, so this will have earliest start time, late start time, earliest finish time, late finish time. Now, as per the question, this is a CPM method. Now, as per the question, the earliest finish time for 3 activities are 10, 12 and 5. Then it's asked that the earliest start time for D will be. Now we know that the earliest start time is equal to maximum early finish time of immediate predecessor, or in this case, now the earliest finish time is 10, 12, 5. Out of this, the maximum is 12, is equal to maximum of 10, 12, 5 is equal to 12. So if we draw the chart for this, suppose this is activity 1, activity 2, sorry, activity A, B, C. Now A, B, C are the immediate predecessors for the D activity, and the earliest finish time for the 3 activities are, this is having 10, 12, 5. Then the earliest start time will be, maximum finish time, this will be 12. We will take always the maximum of the early start time, early finish time of the immediate predecessor. Okay, so the next question. In a project for an activity, the optimistic time T naught is equal to 4 minutes, pessimistic time, sorry, most likely time is equal to 10 minutes, pessimistic time is equal to 16 minutes. Now the expected time is equal to T naught plus 4Tm plus Tp by 6 is equal to 4 plus 4 into 10 plus 16 by 6 is equal to 60 by 6 is equal to 10 minutes. The correct option is C. Now the next question, this is a PERT question. In a network analysis, A, B, C, D, E and F activities having standard deviation 2.5, 4.6, 3.1, 6, 7.3 and 5.2 respectively. ADEF is the critical path. Now, what is the project variance? Now, the project variance is equal to sum of variances of critical activities. Now, we have the standard deviation given. We will just take the variances of the critical activities, which is 2.5 square activity A, activity D is 6 square, activity E is 7.3 square, and activity F is 5.2 square. This will be total 122.58. The next question. An expected project completion time follows a normal distribution with a mean value of 15 days. Now mean mu is equal to 15 days. Standard deviation sigma is equal to 3 days. What is the probability determination factor that will ensure the completion of project in 20 days? Now target is equal to 20 days. Probability determination factor is factor Z is equal to target minus mean by standard deviation. This is equal to 20, or Z is equal to, if we write in abbreviation, the formula is TE minus mu by sigma of the critical path This becomes 20 minus 15 by 3 is equal to 1.67. The correct option is C. Next question. The basic fundamental of crashing of a network is to reduce the project duration by adding extra project cost. Therefore, what is the basic rule to implement the crashing? Now, crashing is an extension of critical path method that considers a compromise between time and cost required to complete the project. Now, it involves direct cost, indirect cost. So, according to the question, it is asking what is the basic rule to implement the crashing. So, basic rule is such that it should have least completion time and cost. Okay, because we know that it needs to compromise between time and cost. So, basic rule is we should choose such critical activity that has least completion time and cost. Now, crashing we have direct cost, that is cost directly involved in the execution of an activity. Example is labor cost, direct material cost, cost of machines, indirect cost is cost not directly involved in the execution of an activity but required for timely completion of project. Now, if we draw the graph, suppose this is the crash time, this is the normal time. Let's this point, let us take it as this is the time axis, next axis, this is the direct cost. Let's take this as normal cost and crash cost. Now, normal time, one is normal time, crash time, normal cost, crash cost. So we have this relation between now we will observe this that the normal time is always greater than the crash time and the crash cost is always greater than the normal cost. This is very important. Now, cost time slope delta C by delta T is equal to crash cost minus normal cost by normal time minus crash time. Okay, so the next question. In a network analysis, crashing is required for reducing the project completion time. The crashing cost and time to complete an activity are 5,000 rupees and 5 days respectively, while earlier the completion time of the same activity is 20 days with 2,000 rupees cost. Then what is the crash cost per day for completing the same activity after crashing? Now we had discussed the new formula, how the formula came. So here, according to the question, it is given Tn is equal to 20 days, Tc is equal to 5 days, Cn is equal to rupees 2000, Cc is equal to rupees 5000. Now crash time cost by time is equal to Cc minus Cn by Tn minus Tc is equal to 5000 minus 3000 by 20 minus 5 is equal to 3000 is equal to 200 rupees per day. Correct option is C. Okay, so I hope it's clear to all of you. Okay, if there are no doubts, then we will move on to the next question. Draw the network diagram for the following activities. This is something like this already we learned in the previous like line balancing and other classes, but just so that we can draw the critical paths diagram easily. So this is just a practice question. So we have the activity AB, which is not preceded A, B, then E is preceded by A and F is preceded by B. Sorry, C is preceded by A. Next is C is preceded by A and D is preceded by B. Now E is again preceded by A and B is preceded by F is preceded by B. So this becomes E and D F. F is, we draw it like this. To avoid confusion. This is F. Now next G is preceded by both C and D. So G becomes and further H is preceded by G and F. So we need to bring G and connect it to F so that first G is preceded by C and D. So since it is together preceded by C and D, we connect it here, and with G and F is preceded by H. Now we put, also we will see that H and I is preceded by J. This we will leave it on hold. First we will draw the E. E is preceded, I is preceded by E. Though, so the next is we draw I. Now E is preceded, I is preceded by E, G and F. H is preceded by G and F. Now we draw the H. Now we will see H and I as preceded by G. So we connect H to I. And now we draw J. Now J is preceded by K. This is the network diagram. Okay, so I hope it's clear. Moving on to the next question. Next also we have one more network diagram for the following activities. Now A and B are the starting activities. They are preceded by, so A is preceded by C. C and D both are preceded by A and E is preceded by B. So we will draw like this. So this is A and B, A and B. Now A is preceded by C, C is preceded by A, D is also preceded by A. So we will have C and D coming from A, critical path, now critical path, longest path in the network diagram termed as critical because if any activity on this path is delayed by certain amount of time, the whole project is delayed by same amount of time. So that is why it is the uh, deterministic or defined for it is defined or deterministic time, which is defined for all type of activities. Now in critical path we find out the total time duration needed to complete the project, and this is done by finding out the slack time, earliest start time, earliest finish time, latest start time, latest finish time, and the critical time, the project completion duration. So the next question. Project contains the following list of activities along with the required time for completion. This is the uh, flow chart. Now we have to make the network diagram and find out the critical path. Now this is 1 to 2. A is the first activity, just 1 day. Now B and C have the immediate predecessor as A. Now this is 3, 4. This is B. B has 4 days. C has activity C will take 3 days. Now next, also D is the predecessor for D, 7 days, predecessor for A. A is the predecessor of D. Next, B is the immediate predecessor of E. This E has 6 days. Now, F is the immediate predecessor of C and D. Now we will use a dummy. Connect D and C. Connect D and C by a dummy. And this is F. Now G is the immediate predecessor of E and F. We will extend this G. with 7 weeks. Okay, so this is the network diagram. Now, possible paths in this network diagram. A, B, E, G. Okay, next is A, C, F, G. Next is A, B, F, G. Now we will calculate the path duration. 1 plus 4 plus 6 plus 7 is equal to 18 days. This becomes 1 plus 3 plus 2 plus 7, 13 days. This becomes 1 plus 7 plus 2 plus 7 is equal to 17 days. The maximum duration is taken by ABEG path. So this will be the critical path. The correct option is A, ABEG. So the next question, crash cost per unit time period defined as we already discussed this, crash cost minus normal cost by normal time minus crash time. Next question, in PERT, three estimates assumed to follow the uniform distribution, Poisson distribution, exponential distribution, beta distribution. We already discussed this is the beta distribution. PERT follows the beta distribution. This is this T naught, Tn, Tp, probability, the beta distribution. Next question. Additional resources deployment to network crashing results in decreasing the indirect cost. Now, we had discussed what is indirect cost, direct cost. So, indirect cost is the cost not directly involved in the execution of an activity but required for timely completion of project. Now, in the network crashing is an extension of critical path method that considers a compromise between time and cost required to complete project. So when additional resources are deployed, they contribute or they add up to the indirect cost. So this is done to decrease the indirect cost. Now the indirect cost we have two things. Indirect cost increases with time always, and increases with time if the project continues for long. Like construction of building, we need to pay the management more money, labor wages, etc., etc. Now the next question, in a project activity times estimate are optimistic time is 2 weeks, most likely time is 5 weeks, and pessimistic time is 14 weeks. Then the variance in standard deviation for the activity is respectively, so we know variance is pessimistic time minus optimistic time by 6 to the power square. This is pessimistic time is 14 weeks, optimistic time is 2 weeks by 6 whole square is equal to 4. Now standard deviation is root over of 4 is equal to 2. So the correct option is 4 and 2, option B. Next question. The network diagram with activities is shown in the figure below. The latest start time of activity is, so this is a very good question. We will just draw. This is the activity A, B, C, D, E, F, G. So the durations are given 2, 2, 12, 7, 10, 3, 4. Now we will draw the early start time, early finish time. Latest start time, latest finish time. We will draw this for all the activities. Now for activity 1, the early start is 0 and early finish is, here it is 0, it is 2. For it is 2. Now for activity 2, early start is 2 and then when we take the early start, we will see the reaching where for the early start we need to find out the starting initial origin points, okay, which is the least. Now for the early finish time, we need to see where the nodes reach. Like here from 2 we see two activities coming, C and D. Now 2 plus 7 is 9 and 2 plus 12 is 14. So we will take the minimum. While going time, we need to take the minimum. So 2 plus 7, 9. Next, for activity 3, activity B, the early start and early finish time. Now we will see at activity this node how many arrows reach. It is only 1. So that will be starting time, early start time is 2. Now early finish time will be 14. Why 14? Since we will see here okay, I will just redo this question. So we will redo this question again. So we will start with the activities. For the activity A, the early start time is 0 and late early finish time is 2. Okay. For for activity B, the early start is again 0 and early finish is 2. Since it is only one activity to this node, so start time and end time are as per the duration. Next for activity C, the early start time is 2 and the early finish time is 2 plus 7 is 9. Now for activity D, the early start time is, see, from 2 to 4 activity nodes 2 to 4 we have activity D. Now from 2 to 4 it is 2 plus 12, this becomes the early finish time. This is 2 and this is 14. Now For activity E, the early start time is now we will see that activity E, how many nodes reach? That is 2 is the early start time and finish time is 2 plus 10, 12. Now activity F, the early start time is here 2, here 2, so or again also here 2. Now here 14, 9 and 12. Out of this 14 is the largest. So we will take 14 and 14 plus 3, 17. So at that node where the activity starts, we will take in account of whatever nodes or arrows reach, and from that the maximum one will be taken. Okay. Now for activity G, we will see that it is 14 and it is 2, sorry 7, 14, 7, 9, 17 and 12. From out of this we will take into account 17 is the maximum, so 17. Now 17 plus 4 is 21. It is the early finish time. Again we will now go backwards. Now for activity G, the late start time is 17 and the early finish time, late finish is 21. Now backwards by taking activity F, we will see the early start time, late start and late finish time is 17. Since the nodes going out of this activity, we will take into account of that. Now for activity E, we have 40. We will see here what all nodes reach backward, which is the minimum one we will take it to. While going forward, we take into account the maximum duration. While going backwards, we take into account the minimum duration. So from here, the minimum is 14 and it is 4. For this, the minimum is 10, 17. For this, it is 0 and 2. And for this, it is 2 and 4. With this, we see that for the activity C, the latest start time is 10. So the correct option is 10. The last question. The total inventory cost becomes minimum at a point when the ordering cost C naught is equal to CC. There is no inventory at this point when the ordering cost becomes equal to carrying cost. Okay, so with this we reach the end of the session. Thank you all for attending the session. If anyone has any doubts, we can discuss. Okay, so if there are no further doubts, we'll end the session. Let's meet again next week. Thank you all.